For this section, we're going to be talking about heating curves. So another diagram to show how matter changes phases. We've discussed these two so far. Heating curves are going to be very similar to our phase diagram. For a substance, it's going to show you temperature and time and how they change as a substance goes from its solid to liquid to gas phase. So a heating curve, here's an example. It's just a graph that represents how a sample changes phases. So your y-axis will always be temperature here. And then across the bottom, sometimes it's time and sometimes it's heat in joules or kilojoules. So let's label the different parts of our heating curve. So this first part is our solid phase. So between A and B, we're heating up a molecule of solid. And so it's gaining kinetic energy as it goes through that phase. So it's getting faster and faster as the temperature rises. So the molecules are vibrating a little bit more in place. Between C and D, we're in the liquid phase. Again, we're increasing kinetic energy between C and D. So our temperature is increasing. So those molecules are moving a little bit faster as the time goes on. And then as you could probably guess, between E and F, we're heating up a gas. So again, kinetic energy in this phase will be increasing. So what's going on between B and C then, between our solid and liquid phase, is melting. And so here, we're changing our amount of potential energy. So our bonds are getting a little bit looser between molecules. And so it's gaining potential energy. So if we notice, our temperature is not changing between B and C. So it's not gaining more kinetic energy, so it's gaining potential energy. And then between D and E, we're evaporating or vaporizing, whichever one you choose to use here. And again, our temperature is not changing, so we're not getting more kinetic energy, but we're increasing potential energy. So why is the curve flat at some portions? So temperature is staying constant. So when your substance is actually melting, when you have an ice cube and it's melting, it's not actually changing temperature. So temperature is staying constant. So all that energy is going into breaking those bonds between the molecules, so between your molecules of water, instead of heating them up. And so it's increasing its potential energy between B and C and D and E. So what about the linear portions between the ones that are sloping upwards? So A to B, C to D, E to F. So here temperature is changing. So the energy is going into heating up the matter. So our temperature gets larger and larger. And so in these segments between A and B, C and D, and E and F, we're increasing our kinetic energy. So we can, if we, instead of had time on the bottom here, we had heat, we could measure the heat of fusion, so the amount of heat required to melt a substance. So we symbolize it with HF between segments B and C. So it's the energy required to change a solid to a liquid. So at B, you get your first appearance of a liquid, and then by the time you get to point C, you're completely a liquid. And then from point D to E, we call that the heat of vaporization. So again, instead of if it was heat on the bottom instead of time, we could measure the amount of heat required to go from the liquid phase. Okay, so our first gas appears here at D, and by the time we get to the end of it, we're completely all gas. And so we call that the heat of vaporization, and it's symbolized with a delta H. So it's the energy required to change a liquid into a gas. And we can go in reverse too. Instead of a heating curve, we can go through a cooling curve. So here we'll start as a gas, go through condensation, into a liquid, into freezing, and then into a solid. So it just goes in reverse. Let's try a couple examples. So where are there two phases present? So meaning a gas and a liquid, or a liquid and a solid. So I would say segment B, we're melting, so we have both solids and liquids present, and at segment D, we have liquid and gas. During one segment, is there only one phase present? So segment A would be one, we have a solid. Segment C, we're at a liquid, and segment E, we're at a gas. Okay, which letters represent a solid? So a solid is represented by letter A on this diagram, a liquid is C, and a gas is E. Okay, what segment is temperature constant? So meaning temperature is not changing. So at segment B, our temperature is flat at 20, so it's not changing there. And at segment D, our temperature is constant. Where's the temperature increasing? So segment A, our temperature is going upwards. Segment C, our temperature is increasing. And segment E, our temperature increases. Okay, what is our melting point then? So melting occurs between our solid and liquid. So melting is occurring at B. So we would go across, read our temperature. So our melting point would be 20. What about a boiling point? So boiling point is going to occur between a liquid and gas. So boiling is occurring here at segment D. So we would go across, read our temperature of 40. Try a couple more on the practice assignment.